So in our last section, we're not really talking about proofs so much, but we are going to add a few possible options for reasons on proofs, and I'll show you what those are in a minute. But we're mostly talking about the properties of isosceles and equilateral triangles. Okay, so what do we know about isosceles triangles? Two sides are equal. What else do we know? One side is not equal. Okay, anything else? Two angles are also equal. Wouldn't they be? Okay, so let's talk about that. If these are the congruent sides, which ones are the two congruent angles? Okay. The ones that are equal to each other are called the base angles. This one that's different is called the vertex angle. Okay, so when they talk about the base angles of an isosceles triangle, they're talking about the ones that are equal to each other. Okay, so those two things go hand in hand, the two congruent sides and the two congruent angles. So we have two sentences right here. We're going to talk about the ones in blue. The ones in green are the proof reasons. So if you want to circle these, they are two if-then sentences. Okay, those are proof options. But the longhand version of these green sentences, this one on the top, if two sides of a triangle are congruent, then what do we know? What did I say goes hand in hand? The two, what are they called? Base angles. The two base angles are congruent. Okay, or they shorten it up for proofs. If isosceles, which is two sides are congruent, comma, base angles are congruent. All right, well, it could go the other way. If two angles of a triangle are congruent, then two sides are congruent. Okay, or if base angle is congruent, then isosceles. Okay, so it goes both directions. If you know two angles are congruent, automatically two sides have to be congruent, and vice versa. Questions? Right? You will see these green options, either homework or test, or possibly both. Questions before we move on? Okay. What do we know about equilateral triangles? Yep. Okay. Tell me a little bit more about the angles. They're all equal, yes. Do we know anything more specific? How they are acute? How did you know they were 60? Yep. They all add up to 180, and if you divide 180 by 3, it equally splits up into 60 degrees. So if you know it's equilateral, no matter what size the triangle is, the angles are always 60 degrees. Okay, I'm going to assume you know that for the test. Okay, it goes both ways. If it's equilateral, we know it's and if it's equiangular, then okay, so we're going to solve some problems knowing these properties. Use some algebra. Let's look at those examples. Okay. The first question you should always ask yourself is what kind of triangle is it? Because then there's some properties that happen. So what kind of triangle is the one on the left? Okay, so if this is equilateral, what do we know about it? All the angles have to be equal to each other. So most often kids would see a triangle and automatically do this. Okay, which this is true. This equation is true, right? But we can't solve it. There's 3 variables in it. So what are each of the angles again? Okay, so that's what we should do, is setting up 3 separate equations, because we know every single angle is 60 degrees on an equilateral triangle. Okay, well this one's solved already. This one we divide by 2. And this one we divide by 3. A lot of kids forget that 60-degree rule on equilateral triangles. Next triangle is isosceles. So if it's isosceles, what was that sentence? Then the base angles are congruent. So your equation is what? Yeah, they have to equal each other. Okay, if it's isosceles, the base angles have to be equal too. Okay, so we subtract 3x. You could go the other way as well. Add 7. We get 7. Questions? We got one example left. All right, so let's look at this one. We have 2 triangles. Okay, they share a side. What kind of triangle is this? Okay, so we know that all 3 sides are the same. Is that true? Okay, because if 3 angles are the same, 3 sides are the same. What kind of triangle is this? It's isosceles. How come? Yeah, there's 2 base angles here that are congruent to each other. So what 2 sides would have to be equal? These 2 right here? Well, see, there's actually 4 lines on there with 1 dash on them. They're all equal to each other. So what would be the best one to start with so that we could solve for a variable? Yep, all of the sides with 1 dash on them are equal. So these would have to be equal to each other because they both have a green dash on them. Well, let's start there then. So we minus x, subtract 4. Okay. Ideas. What should we do to find y? Yeah? How do you know that that would have to equal 6? So all of these sides right here, if we put a 1 back in here, that would mean that this is 6, this is 6, this is 6, and that is 6, right? Well, she said that we should set these equal to each other because that side right there has to be 6 units. So 3y squared minus 6 has to be 6. What would we do first? Okay. Now what? Divide by 3.
You don't have to do the math, it's still equal.
We have to find y.
Oh.
So we got y squared equals 4. How do you get rid of squared? Square root it. That's the opposite of square is square root. Y equals 2. Technically plus or minus 2, but we're just going to go with the positive answer on this problem. Questions? No?